We have a very beautiful question on the board there, extremely beautiful. A body of mass 500 grams suspended from the end of a spiral spring which obeys Hooke's law produce an extension. So let me start solving already. The extension is 10 cm. If the mass is pulled down a distance of 5 cm and released, calculate A, the force constant. So from Hooke's law, the force constant, then the mass of 5, so we have a mass of 500 grams. From here, the extension has to be in meters, so I have to convert my cm to meters, right? So I'll divide here by 10 by 100. That should give you 0.1 meters. The same thing is happening here. My mass must be in kg, so I divide by 1000. So what you will get is 0.5 kg. Now I can solve. Remember from Hooke's law that force is equals to Ke. From the part 1 of the video, this is the part 3. And we want to calculate the force constant. So you make F subject of the formula, which is, so K is F all over E, making K subject of the formula. We were not giving force, but you can get force because I said it in the part 1. Force is mass times acceleration due to gravity. So you divide by extension. So your mass is 0.5 times your acceleration due to gravity, which is 10, divided by your extension, which is 0.1. And of course, punching it in your calculator, what you will get is 50 Newton per meter. Remember the SI unit of force constant is Newton per meter. Why? Because the force is in Newton and the extension is in meters. If you don't know this, please watch my video on dimension analysis. Now, that is for number A. For number B, they want you to calculate the frequency. Remember, from the part 1, that's why I said whenever I do something, try to know it very well. I said the frequency is equal to 1 all over 2 pi root of K all over M. I said it in part 1 of the video. It's there. You are following my channel very well. Now, all you need to do right now, you just impute all these things and you get your answer naturally. Just impute them. So this is 1 all over 2 pi root of your K is 50, already calculated, divided by your mass, which is 0.5. Punching everything in your calculator, your period should give you 1.59 hertz or per second. So this is 1.59. And the next thing is for you to calculate your period. Now, if you only know that your period, which is C, period is 1 all over F. If you want, you can calculate it like this, you get the same answer. Or if you want, remember this formula is the inverse of this. So this is 2 pi all into M all over K. If you use this thing, you will still get the same answer. But let me use the easier one. So try to use this formula, you still get the same answer. So using this, the inverse should give you 0.628. 0.628. So this will just give you 0.628. You want to use the formula, the same thing. This is 2 pi. Remember, pi is 3.142, a constant. So this is 0.5 all over 50. You should get 0.628 seconds. So it's still the same thing. So the next one is for you to calculate the angular speed of the body. For you to calculate the angular speed of the body. Please remember, if from here, let me clean this. Remember, we said angular speed is 2 pi f, right? So we said something like this in part 1 of the video. Please do not forget. And if this is your, look at it. If this is your force, this is your frequency, right? So right now, let me carry this thing and put into this equation. You already know that your frequency, this is the formula for your frequency, right? So putting it here, you have 2 pi times 1 all over 2 pi, right? Root of K all over M. You can see this will cancel this. And if that should cancel that, we have a new formula. That means that the angular speed is just root of k all over m. So that's the formula for the angular speed, root of k all over m. And then you already know this is, the root of your k is 50, you already calculated, and your mass is 0.5. So if you punch it in your calculator, what you should get is 10. Please remember the SI unit of angular speed is rad per second, not meter per second. Please note that this is not linear speed but angular speed. So please endeavor to watch our part 1 of the video. The part 2 is there, the part 3 is there. Endeavor to watch it, solve more example as you can, apply the formula where necessary, and everything should be okay. That is all for this video. Thank you very much.